Factoring and solving quadratics when a is 1. This video is meant to be watched after the first video notes as a supplemental way to solve quadratics. Okay, so this way of solving quadratics is called the star method of factoring. So as you know from the previous video, we always need to have our quadratics in the form ax squared plus bx plus c. Once we know what the a, b, and c values are, we can fill this star out right here. So a times c goes right here, b goes right there, ax and ax go there. So notice the only place you see an x anywhere in this is where it says ax and ax. In the other two openings are where you put your factors. So whatever multiplies to ac and whatever adds to b. So you need two factors that multiply to ac and add to b. Okay, so here's our first one. First example, again, this is from the notes again, that you can just have this second example alongside the first. So my equation is x squared plus 8x plus 12. Remember, I have my a, b, and c. Here a is 1, b is 8, and c is 12. So a times c would be 12, 1 times 12. b is 8. ax is 1x and 1x. And then I need to find my factors. So I'm looking for the factors that multiply to 12 and add to 8. If this is difficult for you, you need to write out all the factors of 12 in order. So start with 1. 1 times what is 12? Well, 1 times 12. 2 times 6. 3 times 4. And then we're back up to 4 again, so I know that I have all my factors. Now I just need to find a pair of these that add to 8, and that would be 2 and 6. So now you put your factors where it says factors. It doesn't matter if I put the 2 on the left side or on the right side. So I'm going to put 2 over there and 6 over here. Then we need to look at these kind of like fractions. You just need to ask yourself, is there any number that divides both 1 and 2 or 1 and 6? There's not, so I can just write my final answer. I just put each of those sides in parentheses. So x plus 2 and x plus 6. It does not matter which side, if you had put the x plus 6 first, it doesn't matter. So that's the factoring part. If I had asked you to factor it, this would be your answer. Now we're going to solve. So we need to set each of these parts equal to 0 and solve. Well, to solve both of them, I'm just going to subtract the 2 and the 6 over. So I get x equals negative 2 and negative 6. So my factoring answer stopped up here. My solving answer went all the way down to there. Okay, here's another one. We're going to fill in our star, and you'll just start memorizing where things go in the star. So on the top one is going to be a times c, which again looks like it's going to be 12. 1 times 12 is 12. b goes down here in the bottom. Make sure you put the negative with the 7. And then we have 1x and 1x. Okay, multiples of 12 that add to 7. We had 1 and 12, 2 and 6, 3 and 4. Well, 3 and 4 look like they're going to be helpful, but 7 is negative, so we need to make sure that we make our 3 and our 4 negative. Always double check your factors. That is the easiest spot to mess up, and it throws everything off. So, negative 3 times negative 4, that is 12, check. And negative 3 plus negative 4 is negative 7, check. So again, put them on either side. Doesn't matter which one goes on which side. Simplify if possible. Anytime a is 1, you're not going to be able to simplify it at all. So we're just going to put it in parentheses now. So x minus 3, you could put 1x if you wanted to, but I'm just going to put x, and x minus 4. So here's my factored form. Now I need to solve it. Again, set these equal to 0 and solve. I'm just going to add the 3 and the 4 over, so I get x equals 3 and 4. Okay, and we'll do one last example where a is 1 here. So AC is going to be 1 times negative 12 this time, so we get negative 12 in here. I'm not sure why it keeps being 12, so don't assume that that means anything. B is negative 11, and AX is 1x and 1x. Okay, so my factors of 12. 1 and 12, 2 and 6, 3 and 4. So again, I can put negatives wherever I want on here, just as long as it makes sense. The only ones that will possibly add to 11 are going to be 12 and 1. I want it to be a negative 11, So if I make my 12 negative and keep the 1 positive, then they both multiply to negative 12, and they add to negative 11, so I'm good to go. Okay, again, when a is 1, you're not going to be able to simplify these fractions, so we're just going to write our answers out. So we have x plus 1 and x minus 12. Again, you can put the 1 in front of the x if you want to, but you don't need to. So here's my factored form, and now I'm going to solve it. Maybe by now you realized whenever a is 1, you just change the sign of your 1 and your 12 to solve. Okay, so now we're going to talk about when a is not 1. Even though it says when a is 1, I meant when a is not 1. Alright, so in this example, I have a as 2. So the first thing I always want to look for is a greatest common factor that I can divide out. Well, there's no common factor between 2, 9, and 10, so I'm just stuck with the 2, 9, and the 10. So my AC is going to be 20. 2 times 10 is 20. My B is 9. And my AX is 2x this time. So it's getting a little bit more interesting. So write out your factors of 20. 1 and 20, 2 and 10, 3 and nothing, 4 and 5, and we're back to 5. So we've got all of them. The only pair of those that could possibly add to 9 are 4 and 5. We're going to keep them positive because a positive 4 and a positive 5 multiply to 20 and add to 9. Now, look at these fractions. We can simplify this one on the left. The one on the right we can't, so we'll just leave it. But on this side, we can divide both of those by 2. So I just get 1x over 2. Or you can just put x over 2. So my final answer is going to be x plus 2, because I'm using the simplified version of it, and then 2x plus 5, because that side didn't simplify. Do not forget to simplify this fraction. So here's my factored form, and now to solve, this one pretty easy. It's going to be x equals negative 2. This other one, you might need to set this one equal to 0 and solve. It's going to come out to be a fraction. So we get x equals negative 5 over 2. Okay, here's another one. This one is a little bit misarranged, so we need to first, before we do anything, add this 4 over and get it in standard form. So we have 3x squared minus 13x plus 4 equals 0. So you always have to have that in standard form. Now to fill out our star. So a times c here will be 3 times 4, so we get 12. And then b is negative 13, and ax will be 3x, 3x. Okay, so again we need to write out our factors of 12, 1 and 12, 2 and 6, 3 and 4. So we need to find a pair of these that add to 13. The only possible pair is going to be 1 and 12. Don't overlook 1 and a factor. A lot of times people forget that those are factors, the most basic factors, and then they struggle with this kind of problem. So I need this to add to negative 13, so both of these need to be negative, and that also multiplies to a positive 12, so we are good to go. Okay, the fraction on the left we cannot simplify, but the fraction on the right we sure can. If we divide both those by 3, we get x over negative 4. So our final answer, we get 3x minus 1 and x minus 4. Here's your factored form. And then to solve this, we set each equal to 0, add the 1 over, and divide by 3. And for the second parentheses, we just get a positive 4 out. Okay, try this one on your own and then restart the video to see my work. Okay, here's what I got. And had to list out quite a few factors here to find it. And I got confused by the 5 and 12 for a minute because I thought, oh, 5 and 12, that'll make 17. But negative-wise, that didn't work out. I couldn't have the 5 and the 12 both negative because the 60 was negative. So then I had to go back up and look, oh yeah, I've got 3 and 20. So 3 and 20 were your factors here. Make sure you simplified that fraction with the 2 3s, and then you're good to go.